So we are given f of x and f of 2x 2 minus x is given 5, and then we want to find the sum of these values. But it looks like it's kind of complicated because usually if you know the function itself, then you can just plug a number that you need to. In this case, we don't have a function itself, which is why we call these functional equations. So if I want to find the values, I like to find the function itself. If I can't, then I should look for some other ways to do what I want. Okay, so like when you look at the numbers, like we are given 1 over 200, 2 over 200, all the way to the 399 over 200. So but at the same time, I cannot find each of these separately unless I know the function itself. And whenever I do have some functional equation, I like to find some specific values, which is like usually helpful to plug some x values that will give us a like concrete number. So in this case, we have x and 2 minus x. If I take their average, which is gonna give us something like this, x plus 2 minus x. If I take this average, the x terms will cancel, you get 1, meaning that if I choose x equals 1 as my first number, then my function will give us f of 1 plus f of 2 minus 1, which is equal to 5. So this is also f of 1, this is f of 1. So meaning that f of 1 is gonna be 5 over 2. So why do I need that? Maybe I don't need it, but it does actually tell us something that we can get at least from here. So after this, you may plug some other numbers just to get the 1 over 200 and stuff. But here's another thing that we have to observe, I would say. So if you look at this number and the largest number in the function, their sum is 400, and if you divide by 200, that is just 2. So meaning that the sum of the number in the first function and the last function is actually add up to 2, which is the same as what we are given. So f of x and f of 2x 2 minus x. So meaning that if I want to do this f of 1 over 200, okay, plus the f of 399 over 200, this is actually the same as the function we are given, which is equal to 5. So I hope that was clear. So because if I plug x equals 1 over 200, so which is going to give me this guy, the remaining will be 2 minus this number, which is the same as this one. And this is not this only one that will have the same relation. If you pair the second term with the second from the last, you do also get the same relation. And if you just do that, so the sum of the first and the last is 5, sum of the second term and the second from the last is also 5. But we have to know how many of these do we have. So we start with the 1 all the way to the 399, which looks like we don't have even number of terms. So since we are just pairing the first and the last, the right in the middle number should be the one that is going to have no pair, right? So if I subtract the middle number from 399, because we start with 1 through all the way to 399, so you will get 398. And when you divide this by 2, so you will get 199. So meaning that we do have 199 pairs. So each pair is add up to 5, or one of them is just equal to 2.5. So we can just use that. F of 1 was 2.5, but that's also the average of the whatever you plug. So that is why we do have the sum of these terms is actually the same as 195 of those pairs. Each pair is add up to 5, but there is also one term in the middle, which is going to be the 200th term, because we do need to pair the first 199 term with the last 199 terms, which is 398 term. So you will get one more term, which is going to be 200th term. So 200th term is just the number, I will say f of 200 over 200. And this is equal to f of 1, which we already know this is 2.5. So if you had this guy 200 times 5, which is 1000, but this is one lesser than that, which is 995, but there is also f of 1, which is 2.5. So if you combine those, you will get 997.5. So this is a nice question about the functional equation. If you like to have a little bit more practice on this, I'll attach another set of questions so you can review those as well.